Solving one-step equations. Surprisingly, it takes one step to solve a one-step equation. Here is an example of a one-step equation that you could probably just do in your head by trying out numbers. And of course, on the high set, there's answer choices. You could try those out as well. However, you need to learn the actual steps for solving algebra equations because it's not always going to be such basic numbers. There might be some negatives or some decimals or some fractions, and trying out numbers in your head just isn't going to work. So let's start by talking about some of the steps you'll do in algebra with regular numbers so you can understand what is actually going on. And the first thing to know is that this sign here, this equal sign, is not necessarily what you think it is. We're used to thinking of the equal sign, especially on a calculator, as meaning the answer is 1 plus 2 equals 3. The answer to 1 plus 2 is 3. That's not what an equal sign is, though. An equal sign is just a way of saying that both sides are the same value. So it is true that 1 plus 3 equals 2 plus 2. Those are both two ways of saying the same value, 4. So this equal sign is kind of like the middle of a seesaw. Here we are on a seesaw, and as long as the weight, I'm just going to say these are rocks rather than people, as long as the weight is the same on both sides, it's balanced. But if I do something to one side, if I take away, well, let's say I add a weight, I've got to do the same thing on the other side or it's not going to be balanced. That is the basic rule for algebra. So once again, using some real numbers, you would probably agree with me that 3 equals 3. I hope you would agree with that. Now, if I want to do something on the left-hand side, and by something I mean add, subtract, multiply, or divide, and in the future we might include things like squaring a number or taking a square root, things like that, I've got to do the same thing to both sides. So if I add a 2 over here, 3 plus 2, that no longer equals 3. 3 plus 2 equals, well, it equals 3 plus 2. As long as I've done the same thing on both sides, everything stays equal. That's the basic idea. Now in a one-step equation, what was that one we had there? Y plus 3 equals 8. The idea in a one-step equation is that you always do the same thing to both sides. You either add, subtract, multiply, or divide. And the object of the game, if you want to think of it that way, is you want to get the variable over here by itself and the numbers over here, and that way you can figure out what the numerical value of the variable is. This one, like I said, you can do in your head. And man, have I had so many students. Why do I have to do the steps if I can do it in my head? Well, I'll show you some that are a little bit harder to do in your head, and maybe you'll understand. But for now, it's y plus 3 equals 8. What am I going to do? I want to get rid of this 3. Well, I can't just erase it. If I take something away on the left side and I don't do something on the right, they're not going to be equal anymore. So what I'm going to do, if I've added 3 to y, now I'm going to subtract it. So if you add 3 to something and then you turn around and subtract that 3 back, you're going to be right back where you started, at y. In other words, the idea is to do the opposite of what is already being done to y. If a 3 is being added, we're going to subtract it, but we're going to do that on both sides. So on the left, we're left with y, and on the right, we're left with 5. So y equals 5. The last step, of course, is to go back to your original equation and see if this works. And sure enough, if I put in a 5 for y, 5 plus 3 is 8. All right, the same is true of multiplication. 4x means 4 times x. Well, if I take a number, and let's do this with a real number real quick, 3, and I multiply it by 4, and then I turn around and divide it by 4, guess what? I'm back to the number I started with. So we're going to use that idea to get rid of this 4 that's being multiplied times the x. So if I'm multiplying x by 4 and then divide it by 4, that's going to have me back to x. Another way to think about that is, and again, multiplication is commutative. So even though we don't write it this way normally, just to make it clear, x times 4 and then divided by 4. Well, think about it. 4 divided by 4 is just 1. So it's really, it's the same thing as x times 1. And x times 1 is simply x. So however you choose to think about it, we're thinking opposites. We're trying to unpack the bag. So right now, there's a 4x over here. We're going to divide not just one side, we're going to divide both sides by 4. And this one's a little harder to do in your head, so these steps will be helpful. Now, you could write with a division sign. Typically, at the level of algebra, you're going to write division like this. I know it looks like a fraction, but there are a lot of handy reasons it's easier to do it this way. One of the reasons it's easiest to do it this way is that when you're multiplying and then dividing by the same number, when you see that same number on the top and the bottom, they just cancel out. 4 divided by 4 is 1, so the only thing that leaves on the left here is an x. On the right, well, grab your calculator or pencil and paper, or if you can do this in your head accurately, but please don't do math in your head on the actual high set. You'll be under some stress. It's too easy to make mistakes. X equals 61. Go back to your calculator, put the 61 in for x. 4 times 61 does equal 244. Now, I'm going to try to do a lot of examples in this video to come up with sort of different situations. So if at any point you want to proceed to the one-step equations on IXL and try some, you can. You can always come back here. I won't be offended much. Okay, so what about subtraction? Well, obviously, the opposite of subtraction is addition. So, in this case, I've got an x, I'm subtracting 87 from it. Well, if you have some money and you give me 87 and then I give you 87 back, you're right back where you started. So we're going to add 87 so that we're left with an x on this side. However, it is against the rules to only add on one side. If you do, the math police will come. You do not want the math police to come to your house. They do not knock, and they come at midnight. All right, and then calculator, or I'm too lazy to get a calculator. I'm just going to do it by hand real quick. X equals 504. Go back to your calculator, plug in 504 for x. 504 minus 87 does equal 417. So the same thing is true with division. Just like subtraction is the opposite of addition, and addition is the opposite of subtraction, multiplication is the opposite of division, just like division is the opposite of multiplication. So if you're dividing by something, let's take a real live number just as a quick example. Let's say you're taking 12. If you divide that by 4, and then turn around and multiply it by 4, you're going to get right back to where you started, right back to the original number 12. Now in this problem, it's written using a division symbol. This is typically not what you'll see as you get higher and higher in algebra. I have seen high-set questions where they ask which equation would be the way you would solve this word problem that you see up above. And sometimes they do have answer choices where the division symbol is used, even though there's variables in it. But you don't see a whole lot of that in general. But I'm going to start out with it this way just to make it very clear. Because what's happening to the y? Well, we're dividing it by 3. What's the opposite of dividing by 3? Multiplying by 3. And of course, I have to do the same thing to both sides. So y divided by 3 and then multiplied by 3 just takes us right back to y. 8 times 3, of course, is 24. We could go back up here and ask ourselves, does 24 divided by 3 equals 8? It does. We're awesome. So the last problem, I use the division symbol. We typically don't use that in algebra. Now on the high set test, they do have questions where they ask you which of the equations below represents the word problem above. How would you solve the word problem above? And occasionally they will have answer choices that do feature variables and also use the division sign. Well, that's their problem. When you're actually doing algebra and you want to make your life easy, you write it like a fraction. And let me use regular numbers to sort of demonstrate why. So this is the number 2/3. Now, if I wanted to multiply that by 3, here's how you multiply fractions. You take, if it's a whole number, you simply put the whole number on top of 1. Now, you probably remember how to multiply fractions. You just multiply straight across. 2 times 3 is 6, and the bottom you've got 3 times 1 is 3. But what I hope you remember is that in fractions you can cancel. So if you've got the same number on the top and the bottom, even if they're not in the same fraction, but they're being multiplied together, you can cancel them out. Now what we're doing is really we're saying dividing the top and the bottom both by 3, but let's not dwell on the rules of fractions. That's another video. So when you've canceled them out, what that means, there's nothing left but 1s everywhere you've canceled it out, and so what you're left with is 2 over 1, or 2. So I hope that becomes very, very obvious to you, because what you're going to do when you're dividing in this case, a one-step equation, is you're simply going to multiply both sides by what you were dividing by. So this is y divided by 3. Well, if I put a 3 there, and of course I got to put a 3 there, and again, you don't have to put the 1, and as long as you're familiar with what's going on, we can cancel. There's a 3 on top, a 3 on the bottom. That's 1s everywhere. So the only thing we have to bring down is a y. That's the only thing on the left side, and 8 times 3 is 24. All right, here's another example that might be end up confusing you a little bit. Let's say we had c plus 18, let's say, equals 5. Well, nothing's changed. We are going to subtract 18 from both sides. So why did I give this example? Well, because when we subtract 18 from this side, of course, the whole purpose of that was to be left with just the variable, just a c. But 5 minus 18, use your calculator if you don't know integers really well, although at this point you really should learn them, is negative 13. Did anything change just because we got a negative answer? Nope. What if we use some really weird numbers? That's what calculators are for. 4.5x equals 17.1. All right, if any of you were saying to yourself, why can't I just do these in my head? Well, good luck, Chester, because this is getting harder than I can do in my head anyway, but the rules still apply. We are multiplying x times 4.5, so what that means is we're going to divide by 4.5. But of course, we have to do that on both sides. Now this looks a little weird. We got decimals in here and it looks like fractions. Remember, this is just another way of writing division problems. That goes away. Nothing left but x on this side. And if you didn't know, and I certainly didn't before I made this problem up, 17.1 divided by 4.5 is 3.8. What if there's a fraction? Well, I do know that the calculator that you use in Nashville for the high set is capable of working with fractions. It's not the most obvious thing in the world the way it works, but it can be done. Hopefully you know how to add and subtract fractions. Anyway, what if I said b plus 7/3 equals 15/6? Oh, that doesn't look like a lot of fun. Learn how to do this on your calculator. You should know how to do this by hand as well, but man, it's so much faster. What's the rule? I add I added 7/3, so I'm going to subtract 7/3, and I'm going to do that from both sides. Well, that leaves nothing but b on this side. Now, if you do not have a calculator that will do this, you'll have to do it by hand. We don't have common denominators here. Go back and review fractions if you need to. But for now, I'm just going to say that 15/6 minus 7/3 equals 1/6. I hope you get that what I'm trying to sort of explain in these last few sections here is that it doesn't matter if the numbers are strange. You have a calculator, you know how to add and subtract fractions, and a lot of times students will get weirded out when a problem includes weird numbers, even though the steps to solve the problem are exactly the same, and you've got a calculator in your hot little hand that can help you with the arithmetic part. At this point, you're probably ready to just go and do some problems for practice. I'm going to do a few more that are just to clarify a couple other situations. What if you have a situation like this? I'm going back to using easy numbers because really the point I'm trying to make is the steps. So we've done b plus 3 equals 9. What if the 3 comes first? Well, it's still the same. Now, if you're doing it side by side like this, I don't know, maybe it's not as obvious, but we're still doing the same thing. 3 is added to b, and 3 is taken away from both sides, and so we end up with b equals 6. But if it makes it easier for you, addition is commutative. That means I can swap places with two numbers that are being added. And if that helps you to sort of make it look like what you're used to, I typically say it doesn't really matter because I like to do my subtraction on the line below and not out to the side. If you add 3 and take away 3, we're left with b. 9 minus 3 is 6. That looks like 6 equals 6. I should not have chosen b. This is supposed to be a b, folks. All right, another quick example that sometimes causes issues. And that's just when the variable is on the right. Well, you're allowed to just, if you want to, if you feel like it's helpful, you can swap things around an equal sign. If you want to always have the variable and whatever's happening to the variable on the left and the number on the right. Now, as we get more advanced, you're going to have variables on both sides of the equal signs. You're going to be moving them around to get them all on one side. But for now, just know that you can swap things around the equal sign, and then all we got to do is what we're used to. C equals 8. So one thing that's kind of nice about getting into algebra is you're not really always in the realm of regular everyday situations. A lot of times it's just algebra problems. And so what I mean by that is if you do a problem like this, now we need to divide both sides by 5. A lot of times you can just leave your answers in fractional form. Yeah, I could go to the calculator and divide 9 by 5. And get, what would that be, like 1.8, I guess? But you don't really need to. Unless the answer choices are in some different format, a lot of times you can just leave it in this form. But again, you could convert it to a decimal. If the answers were in mixed fractions, you could convert it to 1 4/5. All of those are possible, but a lot of times you can just stay just like that.